For this problem, we were asked to find the x-intercepts, or the roots, or the zeros of this quadratic. And so our first step is to make sure everything's on the same side and equal to 0. And so I see that all of my quadratic is on the left, and I have this equal to 0. So that step is done. If there's anything over here, I would need to move it before I could begin. And then I want to see if I have a greatest common factor to pull out. And if I look at my very first value, this is typically going to indicate whether you have a GCF or not. If this is 1, I can't pull out anything bigger than 1. If this is anything else, that number is probably the GCF. You just have to test it for all the values. So let's say this number was 3. I would see if 21 could be divided by 3 and 46 could be divided by 3, and then I would factor it out. If the first number you can't factor out of all three, you probably need to use the quadratic formula to solve, and you can't use factoring. But for us, this number is 1, so I don't have a GCF to pull out, so I can just get started with labeling my A, B, and C. So my A value is in front of the x squared term, which is just 1. My B value is in front of the x term, so that's positive 21. And my C value is the constant, so that's negative 46. And so then I'm going to go and I'm going to use my T-chart to help me find the numbers that multiply to C and add to B. And so my C value is negative 46, so I'm going to try to find the two numbers that multiply to negative 46. I'm going to make my list in a second. And then I need to add to my B value, which is positive 21. So add to 21. So I think using your calculator is the most helpful in this situation because you don't want to miss any of your factors. So I just start by dividing by 1. And I get negative 46. So one of my pairs is positive 1 and negative 46. And remember, you're always going to have two pairs for every set of factors. So I have positive 1 and negative 46, but then I also have negative 1 and positive 46. Then divide by 2, and I get positive 2 and negative 23, and then negative 2 and positive 23. Then divide by 3, that doesn't work. Then divide by 4, divide by 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, all the way up to 23 is basically what I'm doing. And all the way up to 23. So those four are my only pairs. I know I had to type a lot in the calculator, but that helped me be sure that I didn't miss any pairs of factors. And now I want to find the two of those that add up to positive 21. So these, if I add them together, 1 plus negative 46 is negative 45, so that's not it. Negative 1 plus positive 46 is positive 45. 2 plus negative 23 is negative 21, which is close to what I want, but not quite. And negative 2 plus positive 23 is positive 21. So these are the factors that I want. So now I'm going to turn this original quadratic into its factored form. So if I had a GCF, it would be out front, but since I don't, I'm just going to start with x minus 2 and x plus 23 equals 0. And now I'm going to split this into two pieces to be able to solve. So x minus 2 equals 0, and x plus 23 equals 0. And then I can just add 2 to both sides to get that one of my x values is 2. Written as a point, it's 2 comma 0. And my other, I can subtract 23 from both sides to get negative 23. And written as a point is negative 23 comma 0. The one big mistake, probably the biggest mistake in this problem, is assuming that these two numbers are our solutions, that these are our answers, and they are not. So this is negative 2, but our answer is actually positive 2. This is positive 23, and our answer is actually negative 23. So be careful that you don't just circle these and assume that they're your answer, because you do have to go through either this on paper or in your head to be able to get to your final answer. I hope this helped.